All right, part 2 of 8.5, the exponential and logarithmic equations section. I thought I had messed up, deleted example 4. It's not there. We're not doing the problems associated with example 4. So let's just move on. We are looking at solving logarithmic equations in this particular section, or this part of the section. And we're starting with the change of base formula. At first, this seems complicated, but it really truly isn't. You have to come up with some way to remember what's what, how it goes. If you can remember this part here, you're going to be just fine. Log of base b of m, so we have log of m is up top, and log of b is down below. All right, let's go ahead and do this one. Right. So we're going to use the change of base formula to evaluate log base 6 of 12, and then we want to convert log base 6 of 12 to a logarithm of base 3. Step 1, we are going to, here we go, log 6, base 6 of 12 is equal to, based upon this formula up here, we're going to take the big number over the base, right? So that's going to be log of 12 over log of 6. Now we're going to need to use the calculator to give us that number, because that's obviously not something we can do in our head, and it is not just 2. You can't just mark out the logs and say 12 over 6 is 2. We've got log 12, close parentheses, divided by log 6. And we've got 1.387. Let's go ahead and just put 1.387. So this is equal to 1.387. All right, so this is part 1. Yeah, that's a horrible stop sign. We'll just erase that and pretend it never existed. We are wanting to convert log of base 6 of 12 to log of a base 3. Well, we have log base 6 of 12 is equal to log base 3 of x, right? All right, we also know that log base 6 of 12 is equal to 1.387. So we're going to substitute this value in right here. 1.387 is equal to log base 3 of x. And based upon the properties of logs, we know that this is the same as 3 to the 1.387 power is equal to x, right? Because of this, y equals log b of x is, I wrote that down wrong because I wrote it down wrong. This would be the x and this is the y. Sorry, there's dogs outside going crazy. All right, so, and I'm going to do it this way. Log base b of y equals x. There we go. So this is the same as b to the x equals y, which is what we have here, b to the x. So b to the x, which is equal to ry, but in this case ry, the unknown is x. All right, so that's just a review, and I hope I did not confuse you. Oh, all right. Using the graphing calculator, or using a calculator, I should say, it doesn't matter if it's graphing or not, because we're not graphing anything. We've got 3 raised 2, and I'm going to go ahead and put this in parentheses just because I'm overly cautious. And you could even just take the number above. You could even use that second function answer if you wanted to. I find that quite handy sometimes, but to each his own. This gives us 4.589. So that would be 4.59. So x is 4.59. Therefore, if you recall, we wanted to use the change of base formula to evaluate the log base 6 of 12, which we did, which was right here. And then we also wanted to convert it to logarithm in base 3. So that means we need to finish this out. So that would be log base 3 of 4.59. And that would be your answer. You can also have 4.6 if you wanted to. I would not take points off for that. Okay, so not hard, but definitely you have to know this stuff. You have to practice this stuff. You're not going to be able to just look it over and get it right on the test. Even some kiddos who practice this, they don't practice it enough. They just do whatever it is that they're assigned, and if they don't fully still understand it, they should do more. You should do more. If you don't, then you're only hurting yourself. All right? And you can find tons of these problems anywhere, everywhere. Next example, we have solving a logarithmic equation. Okay, now you'll see that it says method 1 and method 2 is missing. That's because we don't use method 2. I believe that was the graphing method. It's nah. Okay, now looking down here at the one for our notes. If we don't have an explicit base, we know that that is 10. And again, because we have log base b of y equals x, can be written as b to the x equals y. That means 10 to the fourth is equal to 2x minus 2. Easy, right? So 10 to the fourth, that means we have the 1, and then it follows by 4 zeros. We learned that way back when. 2x minus 2, so we're going to add 2 to both sides. These cancel. This gives us 10,002, and that's equal to 2x. So now we divide both sides by 2, and x is going to give us 5,001. Voila, easy, right? So easy. So if the base isn't given, 10 to the whatever power is equal to whatever this is, and then you just solve for x. Easy. You guys got this. It's not a problem. Okay, the last example that we have, example 7, using logarithmic properties to solve an equation. Okay, so now we're doing more than just rewriting them. We're doing more than just identifying these properties. We're actually going to use them, all right? And these were introduced in 8.4, right? So, okay, looking down here at the one for the notes, we have solved 3 log x minus log 2 equals 5. All right, well, I know that this 3 is going to go here. So we have log x cubed minus log 2 equals 5. This means I'm dividing. So then we have log x cubed over 2 equals 5. All right, at this point you might be asking yourself, okay, now what do I do? What is our base here? That's right, it's 10. So we have 10 to the 5th power equal to whatever this is, x cubed over 2. Wonderful. So 1 followed by 5 zeros. 1, 2, 3, 4, 5. And then x cubed over 2, forgot the cubed. We want to multiply both sides by 2. So now this gives us 200,000. And in order to find the value of x, we need to take the cubic root of both sides. That's the inverse operations. Grabbing the calculator. Ooh, let's see. Oh, that one's not going to work. It was frozen. Okay, cubic root, that is going to be in the math part. Yeah, there it is, number 4. So see cubic root of 200,000, and that gives us 58.48. So 58.48, and that's it. Okay, so this concludes 8.5. Hopefully we've learned some things, but I'm telling you, this is not hard, but you have to practice it. Practice, practice, practice. Practice makes perfect. And as my husband says, perfect practice makes perfect. Okay, talk to you later.